Right, hi, my name is Aidan Mackey, and this is my presentation on the package sort and transport robot that I created. To start, I was tasked with creating a robot that was supposed to simulate a warehouse robot that could acquire packages from different spots and then help deliver them. I was to use MATLAB in conjunction with the Lego EV3 software, as well as the Lego EV3 brain, computer, and brick for all of my coding for the project. The objective was simple. It was kind of broken down into four steps. First thing I had to do was pick up a colored package from the initial location, wherever that be in the warehouse. Then I had to find the correct colored path to the drop-off spot, and then I need to gently deposit that package into the end, and then return to the initial location. A little more constraints. The robot has to complete all four routes in less than 15 minutes. There will be four packages of four different colors that have to be delivered, and they will be randomly assigned to me at different intervals in order to make sure that my code is robust. It can work with different inputs. All packages must be placed in their specific ending spot, and there should be no exposed circuitry. The components that I used in order to carry out this operation was a small motor right here, and that was driving the gripper arm in order to pick up the pieces. And then I also created a mechanical gear gripper system. What this system did was it was driven by this gear, which would go down and power these gears. And when those gears would reach their limit, enclosing the rubber arms right here, it would actually lift the entire system. So it gave this really smooth pickup motion where it would bring the arms together, grab the package, and then lift up on the ground for safe delivery. And then I also used a gyroscope sensor, which is one of my two inputs that I use, and it's on the back over here. It's kind of hard to see in the picture, but it's over here. And realistically, that gyroscope sensor could have been put anywhere because it just takes rotation of the robot. It doesn't really need to pick up any specific other external inputs other than that. Some more components that I use. This is the underside of the robot. I use a color sensor as my other input device. This was for line following and package recognition. I also used two high torque motors. These motors are recommended for driving robots just because of their size, and they can get over large obstacles, and they just have a lot of power and they have a lot of control over their speed output. And I use the two wheels attached to there. And then I also used a roller ball support in the back, which just it's strong, it's durable, and it would help keep the robot balanced on the back end there. So that was kind of the basic design for the robot I used. There were some issues that I ran into, but I will kind of dive into that later. The initial concept that I used for the software was the following block diagram. So the first thing I did was read the package color using the color sensor. And then I would pick up that package using the motor and gear setup that I talked about earlier. And from there, I would initiate a line following sweep program, which would kind of bounce back and forth looking for the line in order to keep in order to keep the robot on the correct route heading to the right package location. And that was based on the package color, so I had to save that variable to use later. And then when I got to the delivery, I would gently lower the package into the zone by reading some sort of end color in order to trigger that input to drop the package off. Then from there, I just have to go back to the line that I came down the warehouse from and then run it backwards using the exact same sweep line following program again. So that was kind of like the idea for my code that I wanted to implement. And so this is the actual MATLAB code simulation. So the first 15 lines, they were just used to initialize everything and get connected to the EV3. So this command right here connected to the EV3 block, and then these two established the color sensor as well as the gyro sensor. Those were my two inputs. And then I also used two outputs for my motors, A and B. Those were the drive high torque motors for the wheels. And then I also used the smaller motor right here was in import D. Now, these variables right here actually get switched up later, so it's important to just note that as we go on that the actual identities of the wheels do get flipped later in the program. Now, the next section of the code was to read the color of the package and then back up. So this variable right here that was called target was the target color given by the package. And so the robot would start over the package so it would get that initial color. And then from there, I set the speed of the wheels to -30, which would then which I then ran to back up to a point where the grabber could actually pick up the package but still have the robot face in the correct direction. This is where I started using my first feedback system right here. So there's two types of feedback systems I use. There's one that I actually programmed in, and then there's feedback that the motors are programmed with themselves that Lego put in there. And so right here, this read rotation command reads the rotation of the sensor so it can tell you the exact angular position that has already rotated to be used. And so what I did is I set, once that rotation hits 100, then I know that the robot had backed up enough and I could trigger the next, the next part of the code. Later, it also reads velocity. And so it's kind of like a minimum feedback system in that like it can measure velocity, it can measure position, and from there we can actually derive angular acceleration and some other things. The next part of the code was the actual package pickup at the beginning. And so right here, this grab, wherever you see grab, that's the name of the motor that was used to grab the package, which I know is super original, but it makes sense and, checks out in my code. And so again, a very similar feedback system in order to power the grab mechanic. It would just reads the rotation of the thing. And once it had rotated 140 degrees, that was enough to pick up the package and get it off the ground a certain amount. And so once this variable, the test one, which was the read rotation, was greater than the weight variable, which weight is actual reading the current position of the grab motor, then it would break and move on to the next part of the code. And so this is all just going in a line, in a loop. And so once that was all done, then we had to move the robot into the starting spot of the warehouse. And that was just like the exact same code that I used before to back the entire robot up, but I just have to move it forward. So I reset the speed at positive 30 this time up here. And then I had to reset the rotation of both wheels to get them. You always have to reset the rotation of the wheels or else it will mess itself up, because you can be in the hundreds, and then if you don't reset it, then right here, if it's greater than that value, then the code isn't going to work. But yeah, that just runs. It's another feedback system that once it hits 200 degrees, then it's well into the warehouse area, and then it can find the line and start line following to the end drop-off location. And so here's the MATLAB code for the line following. Now, it's broken up into 3 sections. 2 of the sections are really short, and then 1 section is really, really complicated, and we'll kind of get to that in a second. So the first thing I wanted to do was reset the rotation angle of the gyro sensor, because the robot was moving around picking up the package. So I just wanted to reset and get that squared away at 0. I set the wheel speed to 25. And then I started with this while loop. Now this while loop means that the code is just going to run in circles, just continually reading the color of the ground. So this variable color reads the color of the color sensor. And so as this while loop cycles, it'll cycle forever until it's broken. And so that's what the while one means. And so first thing it does is it checks the color. And now if the color is equal to string 1, then we know that we're in the correct thing. And so I had to convert the characters of reading the actual values into strings because they were easier to work with, and MATLAB liked that better. And so string 1 is equal to target, which was that variable I initiated at the beginning in order to, that was the color of the package. And so if the color that the sensor sees, so the color on the ground, is equal to target, then it'll move on. So then it just moves forward. It sets the speed to 25 and then moves forward. This angled test was a different variable that was used for when the color is not the correct color. So whenever that was true, I had to reset the sweep angle function back to the original starting point, which I will get more into here in a little bit. The second part of the code was really, really long, and it's what happens when we get to the end. So at the top here, you can see if the color equals black. So the black was the ending spot that indicated that we had reached the drop-off location. And so, once we had reached that, then we had to deliver the package and drop it off. And so all of these lines of code are just based on that. So the first thing it does in this section right here is turn the robot around. So it reached the end, it just needs to turn around and get it going. The next thing it does is it needs to drop the part off. Now, what was nice about the mechanism I used to pick up the part is that in order to drop the part, all I had to do was take that exact same code and run the motors the other way. So I just triggered the motors the other way, and that would actually drop the part. Now from there, I actually need to get the arms out of the way because it was not good for the robot to drive around with the arms down because they could get caught on the ground and cause some issues. So the next part of the code right here, I had to move the robot. I had to move it up. And so, yeah, and so as it moves along, the next part that I had to do was move the robot forward back, or I had to move the robot forward back into the zone. Um, and so as it goes down through here, that's just resetting the angle and moving the robot back into the zone. And then it's good to go. And so this next part, it actually gets into the next part of the program, but the screenshot didn't allow me to do that. So it was this really long, complicated process all I was doing was turning the robot around, dropping the grabber, raising the grabber back up, and then getting it going again so it can go back to the line following. The last part of the line following code was if the color was anything else. And so if the color was not equal to it, so if it was white, red, or whatever color that was not equal to the target other than black, then we need to start this sweeping. And so the majority of the time spent in the program is actually in this sweeping function. And this function is only a handful of lines, which is super interesting. And so the first thing I did was I had to read the angle of the robot using the gyro sensor here at the beginning. All right, I had to continuously do that in a while loop. And then I would offset the speeds of the motors to 23 and -15. I used trial and error to determine the actual speed of the robot. And this is one of those feedback systems I had to put in myself. So once the angle of the robot had swept through angle test, which was set to 30 degrees. So once the robot had turned 30 degrees, then I had to put in my own system of, okay, stop right here. I had to set variables for the current state of the motor identities, and then right here it was this cool little function that swapped the identity of the motors. So now identity motor 1 became the left motor, and then motor 2 became the right motor. So it would constantly swap these motors back and forth. There's different ways to do that, but I think this is the most concise way to do it. The next thing I would do is I would add 30 more degrees on the angle test, and then the color would still be wrong and it would sweep through. And so what that does, by switching identity of the motors, when I set this speed, now the robot is spinning the other way without having to constantly change these speeds up and alternating them between 23 and -15. It just automatically does that because the identities are changed. So then now angle test is set at 60, and now the robot will sweep back 60 degrees. And if it doesn't find it, it'll sweep back 90 degrees. So if this was like the robot, it'll sweep first to the right 30 degrees. If it doesn't find anything, it'll sweep back 60 degrees, and then it'll sweep back 90 degrees, and it'll sweep back 120 degrees. So it does this, it gets this wider and wider sweep angle that would look for the line. And then once it found the line, if we would go back, then it restarts, the angle is reset to 30, and then the robot moves forward. And so that's kind of how my line following program works, as well as the drop-off location. The live test if I had to evaluate my robot, it performed moderately successfully. It passed yellow. I really liked yellow, which is interesting because yellow is the most complicated path with many turns and switchbacks, but I was able to find the yellow really well and drop it off in the correct spot. It also passed the red, which was a zigzag, and then it occasionally passed blue. I think it passed red and red and yellow because they had sharp corners, which worked really well with the sweeping program. Blue, however, had curved corners. So sometimes that sweeping program would get caught like perfectly in the curve, and then it wouldn't be able to sweep through the blue, and it would lose it. It failed green, but that's because green was really close to the black outline to the edge, and so if it touched that black, then it would trigger the output thing when it wouldn't be anywhere near the end goal. Also, occasionally it would fail blue because it would sweep to green, and the color sensor isn't fantastic. They would read it as blue or black, and it would reset the whole thing, which is not good. And so some issues that I had with my design is that the robot had to enter the end perpendicular, or when it did its 300 or 180 degree turn, it would be offset and it could be off the line. Also, like I said, the color sensor occasionally mistook the blue for black sometimes, or the blue for green. And also the sweep program had to be very precise. It took me almost an hour just playing with those values to get the sweep function to perfectly be able to find the line without overshooting it or undershooting it and missing the line completely. Some modifications that I would make to just the warehouse in general or my robot is I would add a bump sensor. You could also use the ultrasonic rangefinder. However, I like the bump sensor better just because it's more reliable than the range sensor. And what this would do is allow us to have elevated pickup and drop off locations, which is more realistic of how a warehouse would be. And it would also bound the area of the robot. So I wouldn't have to worry about it just seeing black and wandering off. It just, when it bumps the start, it can pick up the thing, and when it bumps the end, it can drop it off. I think that would be actually easier to program. And then the second thing that actually I would change with my robot is I need to put the color sensor on an arm extension. So if you go back and look at the model, the color sensor was actually right between the wheels. And so, well, not right between it, but it was really close to the wheels. And so while these wheels were turning, the color sensor wasn't covering a lot of ground, which means it was harder for it to find the line. It had to be super precise with the values I used. And so if I had put this color sensor more towards the end and longer on an arm, then it would sweep through much more area to do a better job at finding the color. And then lastly, I would use a second gyroscope sensor in order to, I would kind of not reset that position at all so that the robot always kind of has a map of what direction it's facing, because the output or the drop-off locations were always exactly lined up with the starting locations. And so I could use the second gyroscope sensor to ensure that I'm facing the correct direction, just going back and forth. And that would help with um, finishing the drop-off section perpendicular to the end. And yeah, so that's my robot. I think it was pretty successful. The part I'm most proud about is the pickup thing, because I think every other group just kind of drags the part around, which wouldn't be good in a warehouse facility. But just by using one motor, I was able to create a little sophisticated gear arm that was able to pick up and drop off the robot, or pick up and drop off the package, which I thought was pretty cool. And yeah, I would ask for questions, but this is a live presentation, so there we go.